So, hello viewers. Today I will try to explain you why coasting in neutral will save you fuel down the road across the complete fuel tank. Hopefully, this will clear out some of these discussions that often occur about coasting in neutral. However, I have to warn you that coasting in neutral is not safe, or is less safe for you, not for the engine. The engine is the same, it's idling when it's not in gear. But for you, it may be because you lose the ability to accelerate, and in some situations in the road, it will limit your options to escape obstacles, for example. So, coasting in neutral will indeed save you fuel, but it may be a little bit more dangerous. So, let's start with the explanation. A brief overview of the main difference between keeping the car in gear or in neutral. So, let's see. You have your wheels, two wheels that are connected to a part called the differential. Don't need to know what this is for now. This is connected to the gearbox connects to the clutch, and then the clutch connects or does not connect to the engine. That's the role of the clutch, to separate the engine from the rest of the drivetrain. What's the difference between having the car in neutral or keeping it in gear? When you are in neutral, the gearbox is disconnecting the engine from the rest of the drivetrain. The wheels are always turning because they are attached to the ground, correct? So if they are attached to the ground, they move regardless of whether the clutch or not is engaged. And as the wheels move, so do the drive shafts, the diff, and the propeller shaft up to the input shaft of the gearbox. When you have the car in neutral, there is no gear engaged. That means that the gearbox is not transmitting power to the engine, or the engine transmitting power to the wheels. This is disconnected. So if this is disconnected, wheels are being turned because they are attached to the ground and the vehicle is moving, right? But the engine keeps moving. How does the engine keep moving? Because gas is being injected into the engine to keep it moving. That's why we call it idling. The engine is receiving a small amount of gas just to keep running because it is not connected to the wheels. And if this gas were not present, the engine would simply stop or stall. This is a situation where the engine is where we have the car in neutral. Now we look at the situation where we have the car in gear. When the car is in gear, there is a connection between the engine and the wheels. So the wheels spin, the shaft spin, differential spins, the gearbox spins, and connects to the engine. So the RPM is up there. In this case, when you are not pressing the gas pedal, both these situations are only valid when you are not pressing on the gas pedal. If you are in gear, there is a connection between the wheels and the engine via the rest of the drivetrain. What this means is that there is no need for the engine to receive fuel to keep moving. What means is that when you are in this situation, when you are in gear and not pressing on the gas pedal, the engine performs what is called a cutoff or injection cutoff. Let's clarify that this does not report to cars with carbureted engines. I am only talking about electronic fuel injected engines, which are smart enough to cut off the fuel admission to the engine when there is no need, because the wheels are turning the engine via the whole drivetrain. Correct? You follow me? Okay. So, this is the main difference. When there is no connection between the wheels and the engine, fuel has to be injected to keep the engine running. When there is a connection between the wheels and the engine, there is no need to insert additional fuel because the wheels are driving the engine. So it would seem at the first sight that you want to keep the engine running in gear at all times because you would have zero consumption when you are going downhill, right? Well, there is another phenomenon that I want to explain to you, which is called engine braking. And engine braking, you may have seen those posts on the side of the downhill sections of the road where it is stated, "Brake with the engine. Don't overuse your brakes." The reason for this is that the engine has a characteristic. This is the inside of an engine, and this is the combustion chamber. We have the valves here, the spark plug, whatever. Imagine that this is sealed because in some time, in one of the four times of the four engine strokes, one of the strokes is called the compression stroke. What the compression stroke makes is both of these valves are closed, so this is completely sealed, and the piston is moving upward, and is compressing whatever is inside this combustion chamber. This creates a force, a strong force, compression force, that makes it hard for the piston to move upward. And this creates heat. This creates loss. Heat is loss. Imagine when you are pumping your tires, for example, you are pumping your bicycle tires. When you press on the pump, it's very hard and it becomes very hard to pump more air into the tire as it gets fuller and fuller. The same happens in the engine as it turns faster and faster. When it turns faster, it is much harder to press this air. So the faster it turns, the more loss occurs in the engine because the engine is already spinning. When you are in gear, you are at 3000 RPM, for example. When you are at 3000 RPM, this spins 3 times as fast as when you are idling, which is at 1000 RPM, for example. This makes the engine braking effect much more present because if you are pumping your bicycle, if you apply much more strokes, it's much harder and you get tired much easily. So this is the same. This is the phenomenon behind engine braking. It uses the compression of the engine to lose speed. And actually, when you keep the car in gear, that's what will happen. You will lose speed, and it's easy to be aware of this. Just go with your car and then go downhill for a bit in neutral, and you will know that you will gain speed. When you keep in gear, even if it's a high gear, you will maintain your speed or sometimes lose some of the speed. Depends on the downhill percentage. So now that we have covered the introduction, I've made a small diagram that I will show you to try and explain this scenario and why coasting in neutral can be advantageous for you to save fuel. I want to point out that all this explanation is only valid if you never apply the brakes in the whole path of your travel. If you apply the brakes, you are not only using more fuel, but also using more brake pads. So if you have a car ahead of you, never go into neutral because you will have to apply the brakes, and there is no point in this, in saving fuel this way. However, if you have throughout the complete path, if you never face a car ahead of you, which will make you apply the brakes, this will work. So let's start with the first situation. In this, let's see, this is the diagram of the car. This is my car here, starting at 80 kilometers per hour at the top of the downhill section. Then the downhill section ends. Given I was downhill and in neutral, I gain a bit of speed. So I arrive at the bottom of the downhill section with 100 kilometers per hour of speed. Then you see this line here, this axis here, will represent the time in which I am in neutral or in gear. And this final diagram, this part here, it's like a virtual board computer where I have the consumption, the gas consumption across the whole length of time. Okay, so in this time, since I am in neutral, I gain speed and I come to the beginning of of the uphill section, and I start to lose speed. As I start to lose speed, I get to 80 kilometers per hour again. I was coasting in neutral from here to here because of the added speed I gained because I was going downhill in neutral. So this part here was for free, let's say, this part of the travel. And then here I put my car in gear because I want to go the uphill section, and then I go my way. Okay, I continue my journey. So let's analyze the fuel consumption across this complete travel. So in this part we have, let's see, I took my reference, my car, my gasoline car at my house that has a board computer. It's a 2005 Toyota Yaris, which in the America is maybe called the Vitz, I believe. This has a 1.0 gasoline engine, a very small engine indeed, but it will allow us to compare this because it's a gasoline engine, has a high delta between the load consumption and the idle consumption. In the cases where you have, for example, a diesel engine, it may use a bit more fuel just to keep running, and this difference will not be as evident. So let's see that the Toyota will use 0.4 liters per 100 kilometers throughout all this section just to keep idling, because the engine, as I said before, the engine needs to receive a bit of fuel to keep running, as the wheels are not connected to the engine when you are in neutral. So throughout all this time, I am using 0.4 liters per 100 kilometers, for example. Looking at the board computer, it is not unreasonable to take these numbers as reference. So when I arrive at the end of the downhill section, I am at 100 kilometers. I keep in idle or in neutral, so the engine is only idling throughout all this additional time, which I am not using any fuel because I gained speed. And when I reach 80 kilometers per hour, I will have to engage the gear and then step on the gas and use approximately in the instantaneous consumption, the board computer will signal 12.0 liters per 100 kilometers, for example. You may see some differences in your car, like 14, 15. It's up to you. Make your own experiments and come to your own conclusions. So this is the complete cost, the area in gray, the graphic shows the complete fuel consumption throughout the complete path. Now let us analyze the opposite situation, when you are in gear the whole time. You reach the beginning of your downhill section at the same 80 kilometers per hour, but since you are in gear, you will maintain that speed. Let's see, you will not gain any speed. Let's be optimistic, because the tendency is for you to lose a little bit of speed and being in gear, but let's be optimistic. So you reach the end of the downhill section at 80 kilometers per hour. This does not matter because, well, you are in gear, you start engaging the gas pedal at the bottom of the downhill section because you do not have that bonus of the speed. Let's look at the fuel consumption chart. This consumption will be zero from the start of the downhill section because the engine does not need to receive fuel to keep spinning, because the wheels are connected to the engine and the wheels are driving the engine, right? So the wheels are driving the engine, it does not need to receive any fuel, and that's why people will tell you, always keep your car in gear, it will always save fuel, because they are not looking at the whole picture. So you have zero consumption from here all the way to here. But as you will not gain any speed, you will engage your gas pedal much sooner. You will not have that free period of path of travel that the additional speed will give you. So we will be spending during this short amount of time, when compared to the complete downhill section, you will be spending the full 12.0 liters per 100 kilometers. What is the difference between the two scenarios? The difference between two scenarios is that spending 12.0 liters per 100 kilometers during a short amount of time, or the short amount of time that goes from this point to here, will always be more than the amount of gasoline you have to put in the engine to keep it spinning from the top of the downhill section until up to the point where you engage the gear and start pressing on the pedal in the neutral section. This is because all the engine braking that occurs from here to here is wasted mechanical energy. And this wasted mechanical energy is hard to get because internal combustion engines are very bad at converting energy. They are not efficient in any way. Let's see, for every dollar that you put into your gasoline engine in the form of gasoline, you will only get for $1 or €1, you will only get 20 cents out of it, or 20 cents of dollar, because the efficiency of an internal combustion engine is roughly 20%. It depends on whether or not if it's a diesel engine or gasoline engine. Diesel engines typically are more efficient because of higher compression ratios, but the efficiency is still lousy in internal combustion engines. So this mechanical energy that you gain is much better. It was hard earned, because to get here you already spent fuel somewhere down here to reach this top of the hill. So when you are losing some of this energy to engine braking like this, because all this energy that results from all this compression is just heat that will have to be disposed of, and that you already paid for previously with gasoline to arrive to this point, you will always save more fuel. But the thing is, you will always save more fuel than when you keep the car in gear, because of all these losses. The thing is, keeping the car in neutral or coasting down the road in neutral is not it's not very safe. It's always recommended, and you will say in the driving school they will tell you to keep your car always in gear. That makes sense, because when you keep the car in neutral, you lose the ability to accelerate. For example, you may have a situation where you are going downhill. You start your downhill section. There is no car in front. If you have to, for example, you are going down the road in the right, this way, then there is a car that comes and puts itself at front of you. You lose the ability to adjust your speed to maybe overtake if this car gets too slow, for example. If you are on the road and then there is a car in front of you that appears to go in a similar speed as you, and this is you here. This is you, and this is the car in front of you. You are going this way. Okay? If you go in neutral, bear in mind that you will gain speed. You will gain speed, and you may have to engage the brakes somewhere in the middle of the road when distance reaches like this, for example. Throughout your path, you'll have to engage the brakes. This is very bad, because you are putting the car on neutral. You are using fuel to keep the car on neutral because the wheels are not connected to the engine. And then you will have to use brake pads to brake. So this is additional cost. If you put the car in neutral with the car in front of you and you will have to re-engage the brakes, you are not only using more fuel to keep the car running, that will not be used if you kept the car in gear, but also you are using more brakes. So keep this in mind. Only put the car in neutral when there is no obstacle in front of you. Another situation, you are going in neutral, for example, you are going this way, then there is a car that comes, this is you, there is a car that comes and then tries to overtake you. They are using just a little bit of gas to overtake you. You will gain speed. People are not expecting you to gain speed in a downhill section. Well, it's not common, people accelerating in downhill sections, so they may be take more to overtake and all this. So be civil, be respectful, mindful to other people on the road, and don't do anything that they do not expect, for example, because some people will overtake you and then they will return to the side of the road and they're not expecting you to gain speed, and this may cause a crash. So be careful when doing this, and always monitor your brake pedal when you are going downhill. Of course, it's common sense. Do this in roads that you know, and not go downhill on the very high on steep slopes, because, well, of course, you will endanger yourself and all the people in the road.